Okay, now this part 3 video is really specifically focused on the different kinds of questions that can be asked. Most of the vector questions are really straightforward. You sum the actual values together and then you end up with a resultant vector. So you end up having some vector v, some vector w, you add the vectors together, you get resultant vector r. Now, here's the real question. These two concepts where they give you the vectors 2 added together and you're looking really for this resultant vector, here's where the introduction concept about algebra really starts to kick in here. Now, in terms of algebra-wise, if they just give you 2 known vectors and they want the resultant, that seems pretty straightforward. But what if this one was gone and you had, in general, a big old question mark here in the center of your sum, and you had to come up with, hey, here's a vector and here's also its resultant, find the force that's in between the two that causes it to do this. Now it becomes a little bit more of an algebra problem. Now, not any harder, but definitely something that pertains to have a little bit more thought to it. Now, I think these questions are kind of out of order in terms of difficulty. I think I'm going to go to example number 2 before I go to example number 3. Okay? Again, the key here is a good picture and a good understanding of what they're asking you to do. It looks like a relatively short problem, but it does have a little bit of juice to it. So it says, planes flying at 300 miles per hour at a bearing. All right, so first off, we got to get a good bearing concept of what's going on here. 300 miles an hour, 50 degrees to the east. So it must look something like this. 50 degrees going right here, and that's a 300-mile-an-hour plane. Now, if you get to a point where you really need to think about this, stop right here and actually write the vector's components. It's in quadrant 1, so everything's going to be positive, and the answer here would be 300 cosine of not 50 degrees, but its complement reference angle, which is 40 degrees, I plus 300 sine of 40 degrees j. Okay, good job. We got our first vector under control. Now it says in the next part, due to the wind, its true ground speed. Now, if I say true ground speed, they must be talking about the resultant vector. So they're kind of like there's a missing component going on in between. The wind isn't there, but the resultant ground speed turns out to be a resultant that's 317 degrees at a bearing at something else. So 317, somehow it got a little bit faster, and it's a 42-degree angle in terms of its bearing. Now, if I write that one, I'd get 317 cosine of not 42 degrees, but its reference angle, which is going to be 48 degrees? I think it is 48 degrees. 48 degrees? Yeah, I think it is. 48 degrees I plus 317 sine of 48 degrees j. Now, here's the concept. I got to find the wind. And this is nothing more than an algebra problem. How am I going to come up with the stuff that's in the middle between these two? Now, you get really, it's like sum all the time. But if you wanted to find out what this middle piece was, you'd be like, this plus this is that. Maybe I could take this one and subtract that one, and I'd be left with the wind. And that's exactly what you do. You take the resultant vector and you subtract the vector v, and you end up with vector w. And it's a subtraction question is really what it boils down to. Once you get the subtraction, you end up with the vector, then you can find its magnitude, and you can find its direction. That's pretty much the basic concept between these two. So take the resultant and subtract the other vector to find the one that's in between. All right, got the idea? That seems pretty reasonable. I think you probably could figure it out. Okay? I will pause and I'll show you what that work looks like. So it basically turns out that after I found vector W's subtraction between the two, I ended up finding out that the wind was negative 17.7 I, and the second part was 42.7 J. Oops, 42.7. Come on, dude. 42.7 J. Now, that ultimately means to me that the wind was actually blowing in the left and up. It's blowing in the second quadrant is where the wind is actually blowing. And it kind of seems to make sense now. If it was at a 50-degree angle and was blowing a little bit to the west, it would shorten this angle of the resultant vector. That seems to make sense. It was blowing up, so it generally made the speed a little bit faster. That tends to make sense of where that vector is located. Now we would just go ahead and calculate its magnitude, which would be the square root of a squared plus b squared. And you would also find its direction too, as well as doing the inverse tangent of b over a. Now keep in mind that's going to give you a reference angle. It's not going to give you the bearing, which is what the answer is going to need to be. So let's take a look at what those two answers would be. And I unfortunately didn't store these like I was supposed to. Come on, G, get better at this. Alpha A. And I'm going to store this guy right here as alpha B, just to make my work a little bit easier for myself. Second square root of alpha A squared. And you get so used to doing these that it's basically the same magnitude and direction each time. 46.26 or 46.3, that's what this is. 46.3 miles per hour, I think, is how big the wind was. So 40-mile-an-hour wind. And in what direction is it going to be going? Now keep in mind that's in the second quadrant, so our inverse tangent is going to think it's in the fourth. So the inverse tan, alpha b divided by alpha a. Again, it's going to think it's in the fourth quadrant, but it's really in the second. So I'm going to add the 180 degrees to this. And it's going to think it's 112 degrees. Now, this is going to be a little dicey. Actually, I could think about this a couple of different ways. 112 would be one way to think about it. It actually thought it was down here at a 67-degree angle. 67 point whatever degrees, 67.5 degrees. But that would be the same as this angle right here, because those are vertical angles. Welcome back to geometry. And that would be the 67.5 degrees that it would be in reference angle. But that would be a northwest angle that I would have to come up with its bearing. And remember that they are always supplementary. So if I took this negative angle right here and I actually added that to 90, I would end up with a bearing angle of 22.5 degrees. So it's a 22.5 degree northwest wind. Wow. Good job, G. You did it. All right. Go back to that if you need some other questions. Now, this other question is three forces acting on the same object. The key here is to just be consistent and stay with what's going on. Draw good pictures so you know exactly what's going on with each piece. Maybe colors could be helpful too as well. One with a magnitude of 156 at northwest 67 degrees. So this is like a 156, and that's a 67-degree angle going in the northwest. So if I start writing that vector right away, I'm thinking that it's in the second quadrant, which would mean that it's negative, positive, negative 156 sine, cosine of not 67 degrees, but its reference angle, which would be 23 degrees, I, plus 156 sine of 23 degrees J. There we go. There's our first vector. Now we'll go to the second vector. The second vector is one with a magnitude of 48 newtons going in a direction of south 13 degrees east. Now we haven't done a south 13 degrees. That's this way. This is what this vector looks like. That's 13 degrees from the south, going in an east direction of 48 newtons. Let's put that guy down, vector W. Now this is in the fourth quadrant. That's positive negative. And that would mean that this first one would be 48 cosine of, now I'm not going to use 13 degrees, I'm going to use the reference angle, which would be 77 degrees, I think. 13, 10, 80, 77 degrees, I think that's right. 77I plus negative 48 sine of 77J. Be careful of your signs. This is what's a mistake most people make all the time, is their signs. Now let's talk about the fourth or third one. Third one with an unknown magnitude with a direction of southwest. Okay, now this is new. Direction of southwest. If I was going directly southwest, it would be like that. Okay, that's a 45-degree angle. So that's a 45-degree reference angle. And it has an unknown magnitude. Ooh, vector z. X cosine 45I plus x sine 45j. Ooh, that x doesn't look like it's in a cool spot. Let's talk about the resultant vector. Resultant vector has, from adding the three vectors together on the object, is in a due west direction. So the resultant vector ended up going like this. This is where the resultant ended up, going completely west. Now the cool part about that is that if something ends up going due west, then that would mean that its vertical component would be 0. 0j. It didn't go up, it didn't go down. Okay? It ended up going west. Now I don't think it tells you the answer. It says here the resultant force from adding the three vectors on the object is a due west direction. Find the magnitude of the southwesterly force. So you don't know what to put right here. You're kind of like stuck in a concept. What you really want to notice is the algebra. The algebra here basically says that this column right here has to add up to what number? It has to add up to nothing. That's the whole concept here. So if I basically wrote this all out, 156 sine of 23, and then I wrote out plus negative 48 sine of 77 plus x sine of 45. Now we got to be careful here. I may have gotten the signs wrong on this one. That's left and down. That's negative, negative. Negative, negative. This should be a negative right here. Watch out. Should all add up to zip. Okay, now how would you solve this algebraically? Well, these two things here are just numbers. If I added them together and then moved them over there, I could divide by sine 45 and change the sign. Watch, I'll just do the algebra on my calculator to see what's going on. Let's take those two values, add them together, 156 sine of 23, and then take that answer and add it to a negative 48 sine of 77. And then I took that answer, which is this, but if it was added together and then moved over there, it would become negative. So let's just take a negative of that entry. Let's take a negative of that answer. Sorry, let's just make it negative. Then, if I divided it by a negative, it'd become positive again. But then, if I divided it by a negative sine of 45, I would end up with a positive 20. That is what x is. 20 point something, 20.06. Okay, now what the heck did that mean? That was 20.06 miles per hour of the southwesterly force. It says find the magnitude and the magnitude of the resultant. Now, once you found x, you could pick that whole entire concept up and plug it in right there. That was the answer to the first one, the southwesterly force. It's 20 miles per hour. And then I could plug it into this concept and sum this column together and get the resultant's magnitude and so forth. So this is kind of like a twofold question. You want to find the magnitude of the wind, the third force, and then you use that answer to solve it up to get the other. The key is one of the columns will probably add to 0. Okay? Pause on that one and really watch it carefully and see what I did there and come up with an answer. Watch out for the signs. Signs are notorious for causing people to screw up their whole problem, especially if you're doing it in a reference angle point of view with bearings. So be careful. All right, that's part 3. What I will say, and just a small addition to this particular video, and that is over the next couple of weeks, guys, you need to practice the problems because the test looks exactly like what you see on the review worksheets or on the worksheets themselves. And on top of that, if you are not asking questions of all 4 of your teachers, whoever you happen to have, you will not get it. You have to watch people do it over and over and over again until it really sinks in. There will be a moment when the light bulb will turn on and you will get vectors. But the only way to get them is through practice. You've got to practice them. Otherwise, you will struggle with them from beginning to end. So practice and do the job. You can get this done. It's easy enough. I'm super proud of all of you guys. Keep working hard, making your grades better.